In this video, we're going to see how to calculate the critical value Z star for an 85% confidence interval. And we're going to use a Ti84 calculator, but it's very similar to using the Ti36. So how do we do this? First, let's draw a picture. If I want to be 85% confident, then I need to figure out how many standard deviations away do I need to go in order to capture 85%. So we're going to the left and to the right to capture 85%. Now, unfortunately, unlike StatCrunch where we can just tell it that middle amount and it'll give us both boundaries, the calculator of a Ti84 or a Ti36 only gives us one boundary, and it only gives us the boundary when we tell it the area to the left. So here we're looking for two boundaries, but we're only just going to use the positive one. So I could either tell the calculator what's to the left of that boundary, and it'll give me this value here, this z-score. Or I could tell it the other one, as I'll do in a second. So first, if we want to find what is this boundary on the right that cuts off this area to the left, we need to find out what is the total area to the left. So we know the center is 85%, but we don't know how much this is yet. So let's figure this out first. So since we know the entire distribution represents 100% or 1, and we already have 85% in the center, then we can figure out how much is in both sides, basically the complement, by subtracting it from 1. So if we did 1 minus 0.85, that's what we often call alpha, which is the complement. And we get 15%, 0.15. However, I don't want both sides. We only want to know what's on this left side. And since we know that the left and right side are the same, since it's symmetric, basically we can just cut this in half. So we will divide this by 2. And we'll be left with how much is on just the left side. So since the top part is called alpha and we divide it by 2, we often call this amount the alpha over 2. And what do we get is 0.075. So what does that tell me? I know this section right here is 0.075. We also know that the big main section is 0.85. So total to the whole left of that, let's find out what we get. So the area to the left of our z is going to be adding together the first section plus the second section. And that gives us a total area to the left of that boundary of 0.925. So now we know this entire area to the left of our z-score that we're looking for is 0.925. And we can now tell the calculator that area, and it'll tell us the boundary. So how do we find this on the calculator? On the Ti84 and also on the Ti36, you will find that there's an option called distributions, DISTR. And we can find it going to second DISTR. And on here, you will find in the list inverse norm. So you will find it, I think, a little bit further down on the 36, but here it's the third one on the list. So if we choose that third one, it'll ask for 3 things. The first thing is the area. So again, we don't want to tell it the area in between. We need to always tell it the area that's to the left of the boundary we're interested in. And we already calculated that was 0.925. Second, it's going to ask for the mean and standard deviation. And since we are looking for a z-score, we must recall that the mean of z-scores is always 0 and the standard deviation is 1. So we just leave those alone. And we just select paste. And then let's calculate this. Enter. And there we go. It tells us the boundary that cuts off that 92.5%. That boundary, if we round it to 2 decimal places, is 1.44. And that's our critical value. Now, the other option that we could have done is rather than adding these two areas together, Let's see what happens if we just only put that alpha over 2, just that 0.075 into our recalculator. So let's edit this, second distributions. And rather than 0.925, we'll just put the area to the left of the lower boundary, which is 0.075. And when we calculate this one, we end up with the same thing, except here we have the negative, which makes sense because we're going the same amount in both directions, the same number of standard deviations, and we get negative 1.44. So we could also choose to do that, and just remember that when we do write down our critical value, we just take the positive version of it, and we still get 1.44.